Lack of information is an issue we run into with stateless auto configuration. What do I mean by lack of information? Well, what did we receive? We received that prefix, 2001 :A :A 4 /64. And then from there, the device generates its own global IPv6 unicast address. What about the default gateway? Well, the default gateway is automatically going to be determined as well. And how is that default gateway determined? It's simply based on who sent that router advertisement and what was the link local address used to send that router advertisement. So the link local address is going to be utilized as the default gateway. But that's it. So the clients, let's say Windows PCs, they have their IPv6 global address determined. And what else do they have? They have their default gateway. But what about DNS information? What about TFTP information? What about NTP information? To name a few. Well, they need to go get that information from someone else, a DHCP server. We can combine stateless auto configuration with DHCP, and this is known as stateless DHCP v6. So the IPv6 address is going to be automatically generated based on the information in the router advertisements, but in addition to that, there is going to be a flag set that tells the client your other information, such as DNS, TFTP, whatever it is, has to be obtained from a DHCP server. So what I want to do is hack into the ISP router right now and modify the ISP router so that way there, when R4 receives a neighbor advertisement, it is also told that other information can be obtained from a DHCP server. So what we're going to do is we're going to type in configure terminal. We're going to go to interface fast Ethernet 1/0 because that's the interface connected up to R4 in our example. And the command is IPv6 neighbor discovery. So it's still part of the neighbor discovery process. Other config flag. It says right there, hosts should use DHCP for non-address config. So when we type that in, other config flag, and we look at the output of show IPv6 interface fast Ethernet 1/0, you'll see down at the very bottom of this output, it says hosts use stateless auto config for their addresses, and hosts at this interface use DHCP to obtain other configurations. So that configuration flag is set now in the router advertisements, so that way the devices know to get the other parameters, the other configs from that DHCP server. And it was all accomplished using this command right here, IPv6 neighbor discovery, other config flag. When utilizing stateless auto configuration by itself or with stateless DHCP v6, we lack the ability to track those IPv6 addresses that are assigned within the organization because all the devices are just generating their own IPv6 addresses. So we can utilize stateful DHCP v6 instead if we need that control and we want a DHCP v6 server to hand out the IPv6 addresses as well as the other configuration information. However, we are still at the mercy of those router advertisements. Think about the clients for a second. Those clients, as I mentioned, for Windows 7 and Windows 8, they will, by default, try stateless auto configuration first. And we can't shut that off. So what can we do on the routers to make sure that the clients don't automatically take that router advertisement and generate their very own IPv6 address based on that? We need to set a flag in that router advertisement to tell the devices not to use stateless auto configuration for their IPv6 address. Go ahead and find a DHCP v6 server to obtain your IPv6 address. Again, we're hacked in to our ISPA router. It's a joke, folks. I'm not really hacked in. And if we go to the interface fast Ethernet 1/0, which is connected up to R4, IPv6 neighbor discovery managed config flag. So this configuration flag is going to tell the devices that receive the router advertisements, do not auto-configure your IPv6 address based on the router advertisement. You should go and find a DHCP server for your addressing configuration, as well as all the other information that you need as well. So if we type in managed here, config flag, and then we look at the output of show IPv6 interface fast Ethernet 1/0, we'll see down at the bottom it says host use DHCP to obtain routable IPv6 addresses, and they're going to use DHCP to also obtain other configuration information. Our last option that we see here is commonly deployed on CPE devices, customer premise equipment. So our routers at the edge of our network. And this is known as DHCP v6 PD. PD standing for prefix delegation. All of the other options we've taken a look at so far were about a single IP address, assigning a single IP address to a router interface. However, on the customer premise equipment at the edge of the network, typically we are going to need a group of subnets. So not just a single IP address. I need groups of subnets, groups of addresses that I can obtain from the DHCP server in the ISP's environment, and then I can dynamically allocate those through my interfaces and throughout the organization. So the DHCP v6 prefix delegation gives us that ability to not just to receive sets and groups of IPv6 subnets and addresses, as opposed to just a single address that we're going to assign to a single interface.